The road stretches ahead, winding through these rolling hills, their green hues vivid under the late afternoon sun. It's around 5 p.m. A mix of sunshine and the lingering dampness of a March rain. And as I drive, my mind drifts upwards beyond the hills, beyond the sky, to the vast expanse of the universe. The James Webb Space Telescope, it's changed everything, hasn't it? It's given us a glimpse into the early universe, a view that's both breathtaking and bewildering. And now, these new findings, this suggestion that the galaxies are spinning in a coordinated dance, that there might be a preferred direction to their rotation. It's like trying to grasp the scale of these hills, only to realize they're just a tiny ripple in something infinitely larger. In a random universe, you'd expect galaxies to spin in all sorts of directions, a chaotic ballet of cosmic motion. But the JWS, it's showing us something different, something that hints at a deeper order, a hidden structure. And that leads to this mind-bending theory, this idea that our entire universe might be contained within a black hole. It's a strange thought, isn't it? To think that everything we see, everything we know, might be sealed within an event horizon, the boundary of a cosmic abyss, looking at these hills, their solidity, their tangible reality. It's hard to reconcile that with the idea of being trapped inside something we can't even escape. But that's the beauty of science, isn't it? It challenges our assumptions, it forces us to reconsider our place in the universe. This theory, this idea of black hole cosmology, it suggests that our universe might be just one of many, that each black hole could be a doorway to another baby universe. It's like thinking about what lies beyond these hills, beyond the horizon. You know there's more, but you can't see it. You can't touch it. The event horizon, it's like that, a boundary we can't cross, a veil we can't pierce. And yet there's a sense of wonder in it, a sense of connection. To think that our universe might be born from the collapse of a star, from the heart of a black hole, it's a humbling thought. It's like realizing that these hills, these seemingly solid forms, are made of the same stuff as the stars, the same stuff as the universe itself. The theory suggests that the Big Bang, the moment of creation, might have been a bounce, recoil from the collapse of a previous universe. It's a cyclical view of time, a sense that everything is connected, that everything is part of a grand cosmic, driving through these hills. With the sun setting and the rain still lingering in the air, it's easy to feel a sense of peace, a sense of belonging. The universe, it's vast and mysterious, but it's also our home, our origin, our destiny. And even if we're trapped within a black hole, even if our reality is just a tiny bubble in a much larger cosmos, we're still here, we're still alive, we're still exploring. The $10 million telescope, which began observing the cosmos in the summer of 2022, has found that the vast majority of deep space, and thus the early galaxies it has so far observed, are rotating in the same direction. While around 2/3 of galaxies spin clockwise, the other third rotates counterclockwise. In a random universe, scientists would expect to find 50 of galaxies rotating one way, while the other 50 rotate the other way. This new research suggests there is a preferred direction for galactic rotation. The observations of 263 galaxies that revealed this strangely coordinated cosmic dance was collected as part of the James Webb Space Telescope Advanced Deep Extragalactic Survey, or JADES. It is still not clear what causes this to happen, but there are two primary possible explanations, team leader Lear Shamir, associate professor of computer science, said in a statement. One explanation is that the universe was born rotating. That explanation agrees with theories such as black hole cosmology, which postulates that the entire universe is the interior of a black hole. But if the universe was indeed born rotating, it means that the existing theories about the cosmos are incomplete. Black hole cosmology suggests that our observable universe might be the interior of a black hole itself within a larger parent universe. It presents the idea that the Schwarzchild radius, better known as the event horizon, is also the horizon of the visible universe. This has another implication. Each and every black hole in our universe could be the doorway to another baby universe. These universes would be unobservable to us because they are also behind an event horizon. This is a theory championed by physicist Nikodem Poplavsky. Black holes are born when the core of a massive star collapses. In Poplavsky's theory, eventually, the coupling between torsion and spin prevents the matter from compressing indefinitely to a singularity. The matter instead reaches a state of finite, extremely large density, stops collapsing, undergoes a bounce like a compressed spring, and starts rapidly expanding, Poplawski explained. Extremely strong gravitational forces near this state cause an intense particle production, increasing the mass inside a black hole by many orders of magnitude and strengthening gravitational repulsion that powers the bounce. It produces a finite period of cosmic inflation, which explains why the universe that we observe today appears at largest scales flat, homogeneous, and isotropic, Poplawski said. Torsion in the gravity of an extended theory of Einstein's general relativity therefore provides a plausible theoretical explanation of a scenario according to which every black hole produces a new baby universe inside and becomes an Einstein-Rosen bridge, or a wormhole that connects this universe to the parent universe in which the black hole exists. Accordingly, our own universe could be the interior of a black hole existing in another universe, Poplawski continued. The motion of matter through the black hole's boundary, called an event horizon, can only happen in one direction, providing a past-future asymmetry at the horizon, and thus everywhere in the baby universe, the arrow of time in such a universe would therefore be inherited through torsion from the parent universe. As for these new GS findings, Poplawski says, it would be fascinating if our universe had a preferred axis. Such an axis could be naturally explained by the theory that our universe was born on the other side of the event horizon of a black hole existing in some parent universe. I think that the simplest explanation of the rotating universe is the universe was born in a rotating black hole. Space-time torsion provides the most natural mechanism that avoids a singularity in a black hole and instead creates a new closed universe, a preferred axis in our universe, inherited by the axis of rotation of its parent black hole, might have influenced the rotation dynamics of galaxies, creating the observed clockwise-counterclockwise asymmetry. The discovery by the JWST that galaxies rotate in a preferred direction would support the theory of black holes creating new universes, and I would be extremely excited if these findings are confirmed. The JWST, it's given us a new perspective, a new way of seeing the universe. And as we continue to explore, to discover, to question, we're also discovering ourselves, our place in the grand scheme of things. And maybe we'll find that the answers we seek are not out there in the vastness of space, but within us, within the very fabric of our being, within the hills and horizons of our own existence. Join us on our next quest here at Deep Thinker Journal as we dig into more possibilities, look at more questions and answers, and embrace a deep thinking state of mind.